Okay, hello. So let's start. Let's start. So first of all, my name is Arslan, Sayyid Muhammad Arslan. Okay. So I am going to take your chemistry class. This is the first trial class. So you are in class 11 now? Am I
Yes,
correct?
sir. Yes, sir.
Okay, okay, fine. So let's start from the first chapter of your chemistry. I'm in this class. I'm going to uh, teach you some very basic concepts of the chemistry, very basic fundamental concepts like about the atom, about the molecule, about the compounds, and these type of things. So first of all, can you tell me that I have some questions for you. First, can you tell me some basic questions that I'm going to ask you some basic questions so that I'll able to know that key how much you know, so that it'll easy for me to teach you that from where from which level that I should need to take you and to the next level. Okay, so I'm having some questions. So I'm writing these questions. Can you tell me the answers? So the first question is ki you need to tell me the chemical formula. Okay, chemical formula. Just 1 minute. Formula, chemical formula of the first one would be my barium sulfate. The second one would be my ammonium ammonium hydroxide, and the third one would be my aluminium aluminium chloride. So these are the question. Can you tell me the chemical formula of these aluminium hydroxide and aluminium chloride and a barium oxide? Just basic questions so that will easy for me to know how much you know, and then I'll take you from that level and I'll teach you from that level. And some basic electronic configurations like about the first one would be my sodium, electronic configuration of my sodium, then electronic configuration of my chlorine, and then the third one would be my carbon. Okay. So just tell me these basic things. Just
The first one is BaSO4.
hmm.
First, barium sulfate is BaSO4.
BSO4, true. Correct.
I think the second one is NH3OH.
NH3OH.
OH.
True. Hmm. सही
And Al2Cl3.
Al2C
Cl3.
Cl3 ऐसा.
Yeah.
ठीक. ओके फाइन. हाँ तो यहाँ पे Al2 क्यों आया? इफ यू सी कि
Oh, like
क्लोरीन
I think it's Al3Cl3. You know, AlCl3.
AlCl3 ऐसा.
Yeah.
जैसे
I'm not really sure.
क्लोरीन chlorine having a valency of -1 and aluminium having a valency of +3 and 3 basically. So if you cross multiply both, you will get AlCl3. This would be na. I think you're confused with Al2O3. Here the valency of
Yes, sir.
oxygen would be -2. So if you cross multiply, you'll get this 2 here. Understood?
Yes, sir.
Okay. So electronic configuration of sodium, chlorine, and carbon. You're new in class 11, na? Have you learned about anything in class 11, any concept, anything? Like any chapter?
We did the first 3 chapters.
First,
3 chapters.
the first 3 chapters you have done. Okay, great. Fine, fine. So electronic configuration. Then can you tell me the electronic configuration of sodium? Because in the third chapter, I think periodic table, periodic classification. In that periodic classification, the electronic configuration is there, like 1s2, 2s2. So can you tell me if you know, if you know something? Or if you do not know, just tell me the electron configuration that you have learned in your class 10th, like KLMN wali configuration, like 2, comma 8, comma types.
So the first one is 281,
Hmm. 281, true.
287,
287.
7.
ठीक.
And 2 4.
2 4.
4.
करेक्ट 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 करेक्ट. ठीक है बढ़िया बढ़िया. सही है. Okay, so let's start. So can I start from the first chapter or
Yes, so
if
the
you,
first chapter is fine.
huh?
The first chapter is fine.
Okay, first chapter. So the first chapter is your some basic concepts of chemistry. Some basic concepts of chemistry. Fine. So these some basic in this chapter there are some basic things like some scientific notations and significant figures. So in this class I'm not going to explain you about the scientific figures and significant figures because these are the topics which is not a very chemistry wala topic है ना. So I am going to explain you about the chemical compositions है ना. Laws of chemical composition. Law of chemical laws of chemical composition. So there are four laws. There are four laws in chemical composition. So the first law is my law of conservation of mass. Law of conservation of mass. This is my first law. So this law is very known law. So can you tell me what is the definition of this law of conservation of mass? Because everywhere you heard about this law. And have you
The
heard
number
this before? The law of
equal.
conservation of mass. Huh?
Yes, sir. The number of
So can you
reactants
tell me
equal to number of product.
what
Number of reactant is equal to number of product.
number of mass of reactant? No? Mass of reactant.
Yeah,
Yes.
mass of reactant
So
equal to mass.
very simple law, like total mass at reactant side is gonna equal to total mass at product side. Very easy, very simple law. है ना? But there are some questions है ना, on this. So I'm going to give you the question, and it is a very good question. So solve this one. The question is कि if 12 gram of CaCO3 is there, fine. CaCO3 of CaCO3 sample on decomposition gives me 5.6 gram 5.6 gram of CaO and 4.4 gram of CO2. Then find find percent of purity. Very simple. Of sample. ठीक है? This is the question. Can you solve this question?
So,
Can I know
5.6
your
gram.
name? First of all, can I know your name?
My name is Safia.
Safia. So Safia, can you tell me the how I am going to solve this question? So the question is that I need to find just 1 minute. This is a question on percentage purity. Okay, fine. So just 1 minute. I am going to give you some concepts so that it'll easy for you to find. So for the percentage purity, if you need to find the percentage purity, how are you gonna find that percentage purity? I'll explain you. First of all, like just 1 minute. First of all, the percentage purity is I'm going to write the formula of because it is based on this a total mass equals to so that's why. So the percentage formula of percentage purity is the experimental mass divided by my actual mass multiply by 100. ठीक है. So the question is that कि 12 gram of CaCO3 is there, sample is there, it decomposed to give my CaO and my CO2. ठीक है. And the masses are also given to me. Fine. I need to find the percentage purity. How much percentage of purity is there? Because if I add these two, 5.6 and 4.4, what I'll get? I'll get 6 and 4 10 and 5 and 4 9. So it equals to 10. 10 grams. So here I'll get at my product side how much? 10 gram. Fine. And how much I am having? 12 gram of. So that means there is some thing that has happened with 2 gram. So I need to I wanted how much this CaCO3 will gonna this decompose to form these two, and the percentage pure, how much pure is my CaCO3 is there, because if I am having 12 gram of CaCO3, fine. So in that CO3 I am having a pure CaCO3 plus I am having some impurity. Fine. How I am able to get this impurity? Because I know law of conservation of mass. This question is based on law of conservation of mass. The concept that is applying here is percentage purity. Why I'm giving you directly this question? Because you told me that you have completed 3 chapters. So that's why I thought mix some good question with this topic. So this is my pure CaCO3 and there is some impurity. An impurity, how I able to know that there is some impurity? Because at my product side I am having 10 gram of my product, and in my reactant side I am having 12 gram of my reactant. So I need to want my purity percentage. So you need to solve this question by applying this formula, by applying this concept. After solving this, tell me if you able to solve that. If not, I'll explain you. Fine. Okay. So you have 1 minute. Solve this. Very easy question. Okay. Have you understood the question or not?
Yes, sir.
Fine. Solve this. When you're done, you can tell me. Okay. It's very simple
So,
question. It will take just your 30-40 seconds. That's it.
so can you explain the?
Okay, okay. So you are not able to understand, na?
No, sir.
Can I solve? Can I solve for you?
Yes, sir.
Okay, fine. Okay, okay, okay. Just 1 minute. Okay. So the concept is just I'm again explaining you the concept and then I'll solve for you. Just 1 minute. So first thing is my concept, because concept is very important. If you are solving a question, you should know the concept. So the concept is law of conservation of mass. Law of conservation of mass. What it said to me, that total mass which is there in my reactant side, it should be equals to total mass which is there in my product side. So I'm going to calculate the mass which is there in my product side. So at my product side, the mass would be 5.6 plus my 4.4. It will equals to 10 gram. Fine. Is it fine?
Yes, sir.
So this is my experimental mass. This is my experimental mass. Experimental mass. Why I'm saying that it is my experimental mass? Because I have performed the reaction. I have performed this reaction, which is the decomposition reaction. And how this reaction gonna takes place? This reaction gonna takes place like this. CaCO3, it'll gonna decompose when we apply the heat, and it'll gonna decompose as CaCO plus my calcium oxide plus my carbon dioxide. Simple. And how much gram of CaO is there? 5.6 gram. And how much gram of my CO2 is there, which is 4.4 grams. And at my reactant side, how much gram of my CaO or CaCO3 is there? 12 grams. Now, again, the concept is applying this law of conservation of mass. And how? Because weight of CaCO3, it should be equals to weight of my CaO plus weight of my CaCO. But it is not equal. So this is the what theoretical concept. Theory. So in the theory, we'll get your actual mass, and the actual mass would be my 12. From theoretical concept, you will get equal mass. It should be the equal mass. That would be equals to 12 gram, but it is not there. So what I need to do, if I want the percentage purity, what I need to do, I just need to apply the formula of my purity, which is experimental mass. That means 10 gram I'll get. After reaction, I'll get after complete combustion, not half, not 75% or 25% something. Complete combustion. After complete combustion, I'll get 10 gram as my product side, and at as my reactant side, how much it should be there. If this reaction will proceed by following this law, conservation of mass, then how much product I'll get after completing this combustion. I'll get my 12%. This is my ideal concept, but I didn't get that. So if I need to get the purity, what I need to do, I just need to divide this 10 by 12 and multiply this by 100. I'll get easily my answer, and my answer would be something around 80%. I'm having a calculator, I'm using it. 10 divided by 12, i'll get I'll get 83%. 83.33%. Okay, 83.33 percentage. So this is my percentage purity of my CaO. So it means that it means what it means. It means that CaCO3 is my given CaCO3. I'll write given CaCO3 is I'm having some impurity plus my your pure CaCO3. Okay, and how much purity is there in this whole 83.33 percentage. Fine, understood now? Is there any doubt?
No, sir.
Safia?
So,
Huh?
so also, my schools, they started with the mole concept, and
What?
no,
Can you speak louder? I'm not able to hear you properly.
so my school started with mole concept.
Mole concept. I'm going there. This mole after just completing this reaction. Then, acha, okay. So you're telling me that your school didn't explain you about the laws of chemical compositions and all, है ना?
No, sir. Yeah, yeah.
Okay,
They didn't
okay,
teach.
okay, okay, fine. Just give me one minute. Okay, I'm going to check your syllabus. Just 1 minute. Huh? एक second बस. Are you following your CBSE? CBSE
Yes, sir.
syllabus, CBSE curriculum? Am I correct?
Yes, sir. Let me see. Yes.
Okay, just give me a 1 minute. It's 1 minute. Because before class, I saw your syllabus which is there on the portal. So that's why I'm asking. Just 1 minute. Huh? CBSE class 11 syllabus with 2025-26. Just 1 minute. Mm, so, chemistry. So, okay, I'm sharing you the screen with you, okay, and I'm having a CBSE syllabus. So can I share? Okay, I'm just sharing with you. Just 1 minute. Mm, if you see here, can you see the syllabus of yours here? So if you
Yeah.
see that here, uh, laws of just 1 minute. Laws of chemical composition is there in your syllabus. Are you able to see this thing? This is your some basic
Yes, sir.
concepts of chemistry, and this way is your 25-26 syllabus chemistry class 11th. If you see, so that's why I'm teaching you. Okay, fine, no worries. I'm not going to take that because this is a syllabus that will depends on school as well because it's a 11th class syllabus, not 12th. So it's not universal. So I'm going to directly shift to your whole concept. Fine.
Yes, sir.
Is it any issue or can I continue this thing?
So you can start on one concept.
Okay, fine. So, okay, let's start mole concept. It will be fine. So I am okay, fine. I am just explaining you very quickly the three laws, and then I'll comes up to your, because I don't know na ki it may be a chances that will come your in your examination. So that's why. So the second law is my law of definite proportion. Very simple laws. Just two of 10 to 15 minutes will take. So law of definite proportion. It says that law of definite proportion says that ki I'm having what? I'm having my two elements. Let's say two or more elements. I'm having a compound which is composed of two or more elements. I'm having compound consists of two or more elements. Fine. Okay. So from anywhere, any place in all over the universe. For example, I'm having H2O. Okay, this is a compound. In that, I'm having two elements like hydrogen and the oxygen. Fine. So if I take this H2O from your moon, let's say moon, from your earth, I'm taking the sample of my water from moon, from earth, or from where it I can get the from where I will get my water. Like if I go to your north pole, I'll get my water. So the formula remains always the same. The definite proportion says that the formula from where you collect the sample of the compound, which consists of two or more than two elements, the formula will remains as the same, like H2O. Here, two atoms of hydrogen is there and one atom of oxygen should be there. It means that the mass of the hydrogen will be one. So it will add up to 1 plus 1 is 2, because two atoms of hydrogen is there and the mass of oxygen is 16. So the ratio is 1 is to 8. So if you see the sample from the moon and if you see the sample from the earth, the ratio would be 1 is to 8. And a definite proportion. So this is what the law of definite proportion. Very simple. If you take the sample of water, it would be the same. If you take the sample of anything, like if you take the sample of your like if I say that if you take the sample of Al2O3 from anywhere, the formula would be the same. The proportion would be the same. This is all about your definite proportion. And next is my multiple proportion. This is also very simple, similar law, law of multiple proportion. Portion. What it says to me is it says to me that if I'm having two elements, like if I'm having two elements, and what are these two elements? These two elements, like I'm having oxygen, I'm having nitrogen. And from oxygen, nitrogen, how many types of compounds I can make? Like for example, I can make NO, I can make NO2, I can make anything. Like I can make like your you can say कि N2O2 है ना, ये हो सकता है क्या? नहीं, हाँ ये हो सकता है N2O4. Yes, true. So these type of compounds I can make that. Okay, so how many compounds? More than one compound. From these two elements, I can make more than one compound. But what is the key point? What is the key concept here? The key concept is lying in my nitrogen, the fixed mass. What is the fixed mass? If I write the masses, like the mass of nitrogen is 14, है the mass of oxygen is my 16. Here the mass of nitrogen is 14 and the mass of oxygen here, two atoms is there. That means it would be my 30, it would be my 16 and 16. It comes up to 32, not 36, 32. 16 and 16, it would be 32. 16, 32. Here I am having 28 because two atoms of nitrogen is there, 28, and four oxygen, it would be 64. So what I need to do, I just multiply the whole thing with 2 here. So I'll get 28 and here I'll get 16 multiplied by 2, 32. And if I multiply this 28 by 2 here, I'll get 64 here and remains, I am multiplying this by 1, 28, And why I'm multiplying this here by 1? Because I need to make one element constant. I need to take the mass of one element would be constant, like 28. If I'm having only two compounds, like I'm not taking this compound, then it will be very simple. I'm not going to multiply with any number because one mass is my concept. Constant. One mass of my nitrogen is constant. If you see here, 14 and 14. But if I'm taking this one as again, if I'm taking this one also, then I need to multiply this 14 by 2, so that I can compare easily. 28. So one mass is constant. So what this multiple proportion says to me? Multiple proportion says to me, if I'm having a compound, if I'm having two elements, and from these two elements I'm having more than two compounds are formed, like N2O, or I can say that NO2, and more than one compounds are formed, then what happens? The thing that happens is that the other element is going to be in simple whole number ratio. So ratio is, if you see the ratio here, it would be 1 is to 2 is to 2. So this is my simple whole number ratio. What multiple proportion says to me? The multiple proportion says to me is that if I'm having two elements, and from these two elements I formed more than two compounds, or I can say that I can form compounds, number of various different type of compounds, then the other element which is not fixed is going to be divided into a simple whole number ratio, like this: 32 is to 60, like 1 is to 2 is to 4, say whole number ratio. For example, I'm going to give you another example. The another example is my H2O and my H2O2. Here if you see that my hydrogen H2, my hydrogen and oxygen is there, two elements, hydrogen and oxygen. These two combines to form my H2O and H2O2. This is the peroxide, this is my water, H2, simple. So if you see here is that 2 and 16. 2 is the mass of my क्या नाम है, hydrogen, and here 2 is mass of my hydrogen, and here the mass of my oxygen is 32. So if you see that this is the constant masses, and if I divide this, if I take the ratio of this oxygen other element, I'll get simple whole number ratio. The whole number ratio is my 1 is to 2, simple whole number ratio. So this is what all my multiple proportion says to me. So I am going to write the definition, so it'll easy for you to understand later on. So the definition is two elements when two elements combine to form combine to form two or more two or more than two compounds, more than two compounds, then mass of then mass of elements mass of elements which combines with fixed masses, है ना, which combines with fixed masses. So these are the compounds which combines with fixed masses. So, sorry, elements. These are the elements which combines with fixed elements, fixed mass elements, fixed mass of other element show simple whole whole number ratio. Understood or not? If you are facing any difficulty, you can ask me. Understood?
Yes, sir.
Huh?
So what was the last line of the definition?
Last line, show simple
Yeah.
whole number ratio.
No, like the full last line.
Can you
Which
speak louder?
combines, like
Huh?
from which combines that part?
Acha, which combines, again, just which combines with fixed mass of other element. Show simple whole number ratio. Okay, I'm writing again. So combines with fixed mass of other element. Combines with fixed mass of other element. Fixed mass of other elements show simple whole number ratio. Simple. Very simple. Understood?
Yes, sir.
Okay, so I'm giving you one question, very simple question. Here, nothing is going to be added or like which is there in your percentage purity wala part. So very direct forward question, simple, based on this topic, single. So the question is, I'm writing the question. Question is key two metallic oxides. Just 1 minute. Two metallic oxides contain 27.6 percentage and 30 percentage of oxygen, 30 percentage oxygen respectively, respectively. ठीक है? If the first, if the first oxide, if the first oxide is M3O4, find out, find out find out formula of other. Very simple question. So the question is two metallic oxides contains two metallic oxides contains 27.6 percentage and 30 percentage of oxygen. So that means I'm having this metallic oxide, like this is the metal and this is the oxygen. Fine. So the formula would be anything. I do not know the formula. I need to find the formula. What is the formula of the metallic oxide? So how I am going to get the formula of metallic oxide, because I am given with this one metallic oxide. The first metallic oxide is my M3O4. And if you see that in this M3O4, oxygen is 27%. Oxygen is 27
Person.
percentage, 27.6 actually, 27.6 actually. Fine. So you need to tell me the formula of other oxide. 27.6%. So you need to apply the concept of multiple proportion, which says to me is that the ratio of the oxides, the ratio, not oxides basically, the ratio of that element which is not fixed is in the simple whole number ratio. So this is the key concept. You need to apply the key concept. Okay. So apply that and then just tell me the formula. You have 2 minutes, 1 to 2 minutes. Just solve this question and tell me the answer. ठीक है, थोड़ा सा दिमाग लगेगा, अच्छा क्वेश्चन। Can I give you some hint, or you are able to start this question? Do you have any approach, or should I tell you the approach?
Sir, can you explain?
Huh?
Can you explain?
Acha, can I explain to you?
Yes, sir.
Okay, fine. So first of all, if you're not able to solve this question, it's very, very normal, because this is a very good level of question, and anyone who starts learning this chapter uh, at the first attempt, he or she is not able to crack this one. So let's start. It's a very good question. So first of all, I'm writing the metal and oxygen like this. First, in the first oxide which is there, three metals is there and four oxygen is there. If you see that three metals having how much percentage? If I'm having 27, if I'm having 27.6 percentage of oxygen here, so can you tell me how many percentage of metal is there? So how I'm able to get the percentage of metal? Just divide, just minus this 27.6 from 100. You will get the percentage of metal now. So I'm having a calculator. I'm just calculating is 100 minus 27 point how much 6. So how I will get 72.4%. So 72.4%. I'm using the calculator in order to reduce the time, because I am left with very less number of time. Na? So I need to you know tell you in very shorter time. So 72.4 percentage of here, 72.4 percentage of my metal is there. Fine, fine, fine.
Yes, sir.
Hello.
Yes, sir.
So you should speak when I ask you. So the next one is my 30%. So if 30% of my oxygen is there, and 70%, because if I subtract this 30 from 100, I'll get 70%. So that means that 70% of my metal is there. Fine.
Yes, sir.
Okay, very good. So I'm writing like this. Oxygen, I'm writing like this. 27.6 percentage of oxygen, 27 percentage of 0.6 percentage of oxygen is there in 4 atom of oxygen. है ना? 4 atoms of oxygen contains 27.6 percentage. Is it fine? Fine.
Yes.
So
Yes, sir.
if I'm having 30%, then what would be the number of atoms? है ना? Very, very simple logical question. So how I am going to solve this? Just 4 divided by 27.6. So this will give me the for 1% in 1% of oxygen, the number of atoms. How many number of atom of oxygen is there? Like if I'm having X number of atoms, and I am given with like ki I'm having a percentage of 27.6%. I'm saying that in 4 oxygen atoms, I'm having 27.6 percentage. But if I ask you ki in 1%, how many atoms of oxygen is there? In 1%, how many oxygen atoms is there? So you are not going to tell me the integer answer, or you are not going to able to answer me in a whole number manner. Why? Because if you divide this 4 by 27.6, you're not gonna get the whole number. But I am dividing this in order to multiply this by 30, so that I'll get my number of oxygen in 30 percentage, because this is the unitary method. Like if I'm having 10 golgappa, let's say I'm having 10 golgappa whose price is 100 rupees. If I want to know the price of 5 Golgappa, what you will do? You will just divide this na 100 divided by 10. So you'll get 10 and then multiply 5. You will get 50. So the price of 5 Golgappa will 50. So in similar way, what I am doing here is key in 27.6 percentage, 4 oxygen atom is there. But if I need to know key in 30 percentage how many oxygen atom is there, I just need to first know the percentage of one oxygen, then multiply by 30, so that I'll easily get 30 in 30 percentage how many oxygen atom is there. Are you getting my point or not?
Yes, sir.
And 100%, if is there any issue, you can ask me at that point. I'll explain you.
So can you just explain the last part?
Huh?
Can you explain the last part again?
Last part, the 30 percentage.
Yeah.
Okay. So I am saying that ki if I am having 10 golgappa, है ना, similar question. It cost me 100 rupees. If I ask you ki what is the price of 5 golgappas, what you will do? You will do 10 100 divided by 10. This will gives you the price of one golgappa. Fine. And if I ask you कि 5 golgappa का price क्या है, what you will do? You just multiply this by 5, and what you'll get? You'll get 50 rupees. Understood? Similar way, I ask you कि what is the number of oxygen atoms is there in 30%. So what you will do? First initially what you will do? You will get the number of oxygen atom in 1%. If you are able to calculate the number of oxygen which is there in 1%, then you will just multiply this by 30. So easily you can get the number of oxygen atom which is there in 30%. If you see that in 4 atoms, 27.6% of oxygen is there. But if I ask you in 30%, I'm having 30%, then how many oxygen atom is there? And this is the question. So how you gonna can answer me? You just 4 divided by 27.6. You will get the percentage of oxygen atom. You will get the percentage of atom in 1%. But I'll ask you 30%. So what you'll do? You'll just multiply this by 30. Now you'll get this point or not?
Yes, sir.
Understood completely?
Yes, sir.
So it's very basic, simple unitary method, है ना? So this is the unitary method. So after dividing 4 upon 27.6 multiply by 30, you will get the number of oxygen in 30%. So you'll get 4 point something. So I'm having a calculator. I'm using that so that I can easily explain you the concept. If such type of questions will ask in your examination, the calculation will be very simpler to you so that you can easily divide or multiply the thing. But here there is some points are there, so that's why I'm using the calculator for faster calculation. So 4 divided by 27.6, you'll get 0.144. So 0.144 is my number of oxygen atom in 1%. But I'm asking you in 30%. So what you'll do? You'll just multiply this by 30. You'll get 4.34. What you'll get? You'll get 4.34. So 4.34 is my number of oxygen in 30%. Fine. But now the question is not end up here. Now I need to find the number of atom for metal as well. Okay? So how I'm going to solve this? Again, very simple way, the same way. 72.4% having 3 metal atoms. So for 1%, what I'll do? I'll just do 3 divided by 72.4. And for 70%, what I'll do? I'll just multiply this 3 upon 72 by 4 multiply by 70. Again, I'm using my calculator for faster calculation. So just 3 divided by 72.4. Okay, you'll get 0.04. 0.04 is my number of metals in 1%. And what is 1%? This is the percentage of my metal oxide, complete compound. In that complete compound, in 1%, I am having this 0.04 number of atom of metal. Okay, now I'm just multiplying this by 70. Multiply this by 70. What I'll get? I'll get 2.9. I'll get 2.9. Fine. Now, this is the what? This is the calculative thing. After that, there is no calculation is there. Very simple. This type of calculation you should do in this type of question. Now the question is very simple. I'm going to apply my multiple proportion concept. What is the concept of multiple proportion? It says to me is that in the multiple proportion, if I'm having metal oxides, okay, let's say XY. ठीक है भाई XY. Okay, fine. What I need to do? I know that ki my metal should be constant. My mass of metal should be constant so that it should be cancel out by 1 and 1. If you see previously, when I am telling you the concept, if you see that 28 divided by 28, it should be 1:1, है ना? And 28 divided by 28, 1:1. That means that the mass of this one metal, one element should be constant. So if I see that ki I need to find the formula and the one element should be constant, and that would be my metal. That would be my metal. This thing will be constant. So it means that if the mass of my metal is constant, or then it will be very simple for me. It means that I'm going to apply this thing. Like I'm having metal and oxygen here, and 2.9 I'll get here, and 4.74 I'll get here. This is what? This is my number of, this is my number of atom. This is my number of atom. This is my number of atom in 70 percentage. This is my number of atom in my how much? 30 percentage. 30%. 30%. Fine. But the question is that ki I am not able to write this formula like this. This is not my answer. Why? Because metal is never gonna be 2.9, or the metal never gonna be 4.34. It should be a whole number. है ना? Like M2O4, like M2O3, है ना? This thing, like this type of thing. I should need this. This is not possible because metal should be 1 or 2 or 0. It will never be in a fraction because it is a number. है ना? Fine. So what I need to do, I just need to divide this by 2.9 because I am having two. I am comparing the two oxides. The one would be M3O4 and the other that I need to know. That I need to know X or Y. I need to know what is X, what is Y. So I need to just divide this by 2.9. Here same 2.9. Why I'm dividing this here by 2.9? Because metal should be 1:1. It should be constant. So that's why 3 divided by 3, it should be constant. 3:3, it should be constant. 1:1. Hai na? So I am dividing 2.9 divided by 2.9. Constant. So metal would be 1. Fine. Now if I divide this 4.34 divided by 2.9, what I'll get? 4.34 divided by 2.9. What I'll get? I'll get 1.5, around 1.5. What I'll get? 1.5. Now I am very close to my answer. So if I need to convert this into a whole number, what I need to do? I just need to multiply this by 2. If I multiply this whole by 2, so that it will convert into a whole number. Like 2 multiplied by 1.5, which will be 3 by 2 multiplied by 2, it will be equals to 3. So this is my atom. This is my number of atom of my metal, M2O3. This is my final answer. So this is the common sense. Here I am just applying the common sense. Here nothing is very difficult. Just again listen what I am saying to you. First, initially I need to find how many number of atom of metals and how many number of oxygen atoms are there in this percentage, like 70% or 30%. If I able to know how many number of atom of a metal in 70% is there, or how many number of oxygen atom is there in 30 percentage of this my oxygen, then I am able to convert this into a whole number, because these number are not my whole numbers. I need to convert this into a whole number. So what I need to do, I just need to divide by 2.9. Why I am dividing this by 2.9? First thing, it is a it is the smallest number. If I compare this 2.9 and 4.774, 4.74, this is the smaller number. So if I divide this smaller number, I'll get 1:1. And this is the concept of 1:1 is the concept of a multiple proportion, which says to me that in multiple proportion, my one element should be constant. The one element should be constant. So if you see here, my one element is constant, because 2.9 divided by 2.9, my one element is constant. And if I divide this by 2.9, I'll get 1.5. Now I just need to multiply this by 2 so that I'll get my whole number. So this is the maximum hardest probability of type of question that it may a chance that it will come your exam. And most probably this type of question is not going to be come at your exam, because you are saying that in your school there is no such type of topics that is teached, है ना?
Yes, sir.
Hello,
Yes, sir.
am I audible?
Yes, sir.
Okay, fine. So are you the only student which is there in this class, or there are some other students also? Because I am seeing that there are other students also there. Because I do not know, I just told that I should take the class. So are you the single student, or the other ones are also there?
No, sir, I'm single student.
Safia?
I'm single student.
Acha, okay. So I need to teach you only, na?
Yes, sir.
Okay, fine, fine. So Safia, I'm pronouncing the right name?
Yes, sir.
Okay, fine. So are you able to get this thing or not? If any issue, you can ask me. I'll explain you. Okay, fine. But just you need to tell me at which point I need to explain this again.
No, sir, it's okay.
Understood? So
Yes,
this
sir.
is the maximum hardest level question. Take it. And most probably it will not going to be come in your exam because you are not in your school. This topic is not covered. Take it. So this is all about, and there is another law which is there, which is reciprocal proportion, but it is not important because in general it is not important. And if in your school it is not covered, then it make no sense to tell you. Just you can know the name reciprocal proportion. That's it. Okay, so three laws that we have covered. The first law is your law of your conversion of conservation of mass, and the next one is my definite proportion, and the next one is my your multiple proportion, and the other one is my I am just writing the name law of reciprocal proportion. Just reciprocal proportion. You do not need to worry about this because it's not very important. Okay, the things which are important I'll told you. Okay, so this is the question on purity, but the concept which is there is my law of conservation of power. So in this question, what you are able to know, what you are able to should learn for in this question, what are the points that you should know. So the first point is that the question are not directly going to ask in your exam ki just tell me ki what is law of conservation of mass, or just tell me the number of how many number of moles are there, because you're writing an exam of your of your higher class, like you're in class 11, you know, so you're in your higher schools. So in that there is no direct type of questions are going to be asked. There are some difficulty levels, there are some catches, like in this question the concept is applying here is law of conservation of mass, but behind this concept you need to know about the concept of percentage purity, and the percentage purity sets to me the experimental mass which is there in the question. Experimental mass is always going to be there in the question, which is after applying, after performing the this chemical reaction, you will get your masses, and just you need to add these masses, you will get 10, and the mass which is there in the reactant side, which is going to be equal to the mass of the of your product side if it follows the ideal condition, which is law of conservation of mass. If it follows the ideal condition, then the mass would be 12. Just you need to divide 10 by 12, multiply by 100. This is the solution of this question. Above things are just the explanations. I'm just explaining you and again and again. This is just a very small solution which is there. Okay? This question
Yes,
is
sir.
just like this. And 10 divided by 12, multiply by 100, you get 83.3. Very simple question. Now, the next thing is definite proportion. Definite proportion says to me is from anywhere I am taking the sample, like I'm taking the sample of my water, I'm taking the sample of anything from any place, the proportion would be the same. Like H2O, water would be everywhere would be hydrogen, two atoms of hydrogen is there, one atom is of oxygen is there. Everywhere it would be same. Everywhere it would be same. And the definite in the definite proportion, which will be 1:8. But now the next one is my multiple proportion, which says to me if I'm having two elements, it combines to form different type of compounds. So if I fix one element, and if I take the ratio of the other element, it should be in the simple number of ratio, simple ratio. Take a simple whole number ratio. And the simple whole number ratio application here. Here is the application of this. What is the application? If you see, I'm not able to get the simple whole number ratio. So what I need to do? I just need to divide this by the smaller number, 2.9, which will be the number of my metal. Why? Because metal should be constant. One element should be constant. Why I'm taking the metal as constant? Why I'm not taking the oxygen as constant? Because this is the question. है why how you are able to know कि metal is constant, why oxygen is not constant? If I need to make oxygen as constant, so why I should not taking this thing? Because oxygen is there in my large number of quantity, which is 4.34. If I divide this thing by 4.34, I'll get again 0 point something. and this is I'm not able to get the whole number. Understood? So in order to get the whole number, what I need to do, I need to divide this by smaller number, and the number which I am dividing is the element which is there in my constant proportion, which is there. Here is the metal. So if I divide this by 2.9, 2.9, I'll get 1. So 1 is my metal which is there in the constant proportion, and 3.4.34 divided by 2.9 is the oxygen which is there in 1.5. Just I need to, this is the simple whole number ratio, I just need to multiply this by 2, I'll get 2 is to 3. 1.5 multiplied by 2, I'll get 3 na. So the my formula would be M2O3. Very simple. Understood everything, or is there any issue?
No, sir.
Okay, fine. Now I am moving towards my mole concept. Mole?
So, I'll be back in 2 minutes.
Huh?
I'll be back in 2 minutes.
2 minutes. Okay, fine, fine.
Yeah.
Okay, fine. When you will back, you can just call me, okay?
Yes, sir, I'm back.
Okay, okay. Okay. So now I'm starting the mole concept from very basic. Okay. So can you tell me what is mole? How much you know about mole? What is mole?
So, I don't really know that much.
You don't know anything.
Nothing.
Okay, fine, fine. Okay. So do you heard about 1 dozen do you heard about what is dozen, like 1 dozen of banana,
Yes, sir.
है ना? So what is 1 dozen?
12 bananas.
1 dozen of banana. If I ask you, can you give me 1 dozen of banana? So how many number of banana you'll get to give to me?
12.
12, है ना? So the number which is associated with 1 dozen is 12. So this is the key concept here. Again, what I'm saying is, you 1 dozen banana. It means that there is a number which is associated to 1 dozen, so that you are giving me 12 number of bananas to me. है ना? I'm not asking you ki just give me 12 bananas. I'm just asking you to give me 1 dozen. And from in this 1 dozen, there is a number which is associated, and the number which is associated is 12. Similarly, in the mole concept, mole is nothing just a number. It is nothing just a number which is Avogadro number, which is 6.022 multiplied by 10 to the power 23. It is a number, there is a number which is associated with the mole, and here the number is 6.022 into 10 to the power 23. And what is the significance of this number? What is this number? Why this number is very large? Because if you see that it is 10 to the power 23, it is a very large number. So why I need to took this very large number as one mole? And the question is that why? So the answer is lies in the number of particle that we are going to associate with this one mole, and the number of particle or the number of compound or the number of molecule or the number of element that we are going to associate it with this number of this mole is are in very small size that we are not able to see from our bare eyes. है ना? We are not able to see the atom, we are not able to see cell, we are not able to see electrons, we are not able to see neutrons, we are not able to see protons, we are not able to see microscopic particles and the electronscopic particles. So if we are not able to see that, that means they are very small in size. So if they are very small in size, if in a single matter, if I am taking this is a stylus pen that I'm using, है ना? So this is a matter is what? Matter is something which occupies the space, है ना? It is having a mass, and which occupies the space is my matter. So if you see that in this stylus pen, there is some billion number of atoms are there, billion trillion number of atoms are there. So in order to associate a one number, so that for the easier analysis, easier observation, easier calculation, easier understanding, in order to understand these particles, these number of molecules, we need to associate some number, है for understanding, for analysis. So the number that we associate is here mole. Why? Because it is very small. If I ask you, give me 1 mole of pen, you are not able to give me 1 mole of pen, because pen is a quantity which is having a very large size if we compare from the atom. And my complete room, my complete flat is going to be filled up with this amount of pen, because it's a very large number. So this number is basically associated with the particles which are very small, which we can't see from our eyes. Understood? So here the mole concept starts. So now I'm going to start the calculations of the mole concept. So do you understand what is mole? Understood or not?
Yes.
है
Yes, sir.
It's just a number. Fine. So there are three types of ways that I'm going to associate the moles. Like the first one in terms of my mass. The second one in terms of my, I can say, volume. In terms of my, I can say, number of particles. Number of particles. So there are three ways that I can calculate the number of moles. And what are the three ways? The three ways is let's take an example. If I'm having Al, okay, if I'm having Al, just 1 minute, 27, no. Okay, if I'm having Al as 162 grams, fine. I'm having Al, aluminium 62 gram. If I ask you how many moles of Al is there in 162 gram, if I took 162 grams of aluminium and ask you how many number of aluminium particles are there, can you tell me how many number of particles of aluminium is there in 162 gram of aluminium? Can you tell me? Hmm?
Um,
Fast, fast.
162 to 6.02 10 is 23.
6 point?
No, is it like 162 into
No,
6?
I have given you a mass. Fine. And then I ask you how many number of particles. So here the mole concept is required. Just give me 1 second. I'm just need to give one message to someone. ठीक है हाँ. Okay. So what I was telling you is 162 grams of aluminium is there. So I am asking you ki how many number of aluminium is there in 162 gram. So what you'll do, you will just need to know about the mole concept. So the mole concept is that if you need to get moles and mass is given mass is given to you. So what you need to do, you need to divide the given mass divided by molecular mass. The molecular mass, if you divide the molecular mass with the given mass, you will get number of mole. ठीक है. Or if you need, if the volume is given to me, if volume is given to me, this is given, then what you'll do, you'll do the volume which is given, this is given, divided by 22.4, and this is at STP. And what is STP? I'll tell you in next class. Okay. And then if the number of particle is given to me, number of particles is given to me, then what I need to do? I just need to divide this number of particle divided by Avogadro number. Simple. And the Avogadro number is this 1 mole. The Avogadro is the scientist that tells us this is the number that we are going to associate with the mole. So that's why we are saying this. This is the Avogadro number, and the presentation is Na. Simple. Take. So this is the number of particle divided by Avogadro number. Here given mass upon my molecular mass. Here volume given divided by 22.4 liter at STP. Very simple. So this is how you're gonna calculate the number of moles. How many number of moles are there? Okay. So 62, it is the mass which is given to me. So 162 and divided by molecular mass. What is the molecular mass of aluminium? Can you tell me? You are in class 11th now, and it's about August. So can you tell me what is the molecular mass of aluminium in class 10th if you learned? Have you learned or not?
I don't remember.
So I'll tell you the molecular mass of aluminium is 27. Okay. So if I divide this by 27, I'll get how much? I'll get 6. So that's why I'll give you this. This is the calculator. For easier calculation, I'll initially calculate that. So this is 6. 6. So 6 is what? 6 is 6 moles of aluminium is there. 6 moles of aluminium is there. Take in 162 gram. So if what I have asked you, I have asked you number of particle. How many number of particles is there? So just you need to equate this number of moles. Mole equals to number of particle. Number of particle divided by Avogadro number. So what you need to do? You just need to multiply this by Avogadro number. Mole को Avogadro number से multiply कर दो. Simple. So mole is 6 multiply by Avogadro number, which will be Na. है ना? So 6.022 multiply by 10 to the power 23. So this is my answer. Got it?
Yes, sir.
है ना? Understood or not? If you are
Yes,
facing
sir.
any difficulty, you can ask me here. I'll explain you.
No, sir.
Any
No doubt.
question? Huh?
I have no doubts.
Okay, fine. So from the next class, we'll continue from the mole concept. ठीक है? Complete mole concept. Everything from the basic. है ना? From here. From here. We'll start from here. Mole concept and we'll do your the upcoming topics, which is there. I think what your empirical mass and another etc etc. ठीक है? Fine?
Okay. Yeah.
है ना?
Yes, sir.
Have you enjoyed?
Yes, sir.
ठीक है. Okay. So you may leave now. Thank you.